Hello, John here, and we are in video 3 of tutorial 36, and tutorial 36 is all about the text scrolling, because I was asked by somebody if I could write some text scrollers. So we've done a basic text scroller in BASIC, and then we converted it to machine code to see what it was like, and now this time we are doing a smooth text scroller, and this is going to involve manipulating the character set. So little lesson in memory. In a computer, memory is classified as an item that can be switched off and on like a light. So if it's switched on, then it means it's holding data, and if it's switched off, that means it's holding no data. So in a computer there are thousands of these bits. Now, to make life easier, they grouped these bits into bytes, so you get 8 of these bits in a byte, and it allows you to store a number from 0 to 255. And then memory is a stack of these 8-bit bytes on top of each other that can be addressed between 0 and 65535. Yeah, I think that's right. And so that the characters are basically a 64-bit matrix in an 8x8, which, as you can see on the screen. Now, you've got to remember that the memory's in a stack that goes either top to bottom, bottom to top, doesn't matter how you look at it. But these characters are defined in 8-byte clusters. So the @ sign is stored at D000 or 8000 on the VIC. The A character D008 or 8008, B, and so on, and they're all stacked upon the top of each other, and it's easy to reference when you line them up vertically. It's dead easy. You can scroll them up and down and all that, dead easy. But when you start scrolling horizontally, you have a little bit of extra complexity. So we want to move this @ sign in this direction by 1. So we scroll the bits across 1, and the result will be put into our carry flag. So we need to be able to scroll these 8 bytes across and remember what the state was in the carry that then can be put into the next byte. Now, we only have 1 bit for the carry. We don't have a carry byte, so we're going to have to do a little bit of jiggery pokery and a bit of inventiveness to make it work. So there you go. So that's the second scroll, and as you can see, this time this bit here these 3 bits that were here have now moved into the pseudo carry byte, which then will be moved into the next character. So what we're going to do is we're going to use the accumulator as the carry byte. So we're going to read the carry on every byte that we rotate, and we're going to put it into the accumulator. So the accumulator then will have a horizontal representation of the vertical bit carry collection. Wow, that's a bit of a mouthful. So effectively we're going to take the bit off the byte in the character, put it into the accumulator, take the next bit, put that in, take the next bit, put that in, take the next bit, put that in, and then we've got the accumulator, which represents the 8-bit carry byte. You with me? Hope so. Then we're going to take that accumulator 8-bit carry byte and we're going to put it into the next byte. So we'll look at the first one. If it's a 1, we're going to set the carry and roll it in. Next one, if it's a 0, we won't set the carry to and roll it in. And we're going to work our way down there. That'll allow us to move this bit column from here into this bit column here. Now remember, memory stacked horizontally, and we're trying to move vertical column from one place to the other. So we've got to do this 8 times. So we've got to shift this, remember what the state was, put it in the accumulator, shift this one, and do the same. And then we have to do the reverse on this side to roll it in. So this is a sort of representation what we're going to try and do. So we're going to take a character, we're going to shift it, it'll fit the it'll populate the accumulator. Shelf is moving. The accumulator with the carry bit profile. Then we're going to shift that into the next character, which will then pop out the carry bit on that side, which we need to put back into the accumulator. Yes, I hear you saying it. How are you going to do that with one accumulator? Well, this is where we get inventive, and we do it, and we do this from the last character and work our way to the first character, because we want to scroll this way, which means we've got to roll it this way, which means you've got to process the characters in reverse order. So we're doing that way. If we were scrolling the other way, we would start at this side and roll that way. Got it? Now, when we put the new character in, we have to get it from the character ROM, and we're going to have another character out of sight on the screen that's going to contain the character that's defined in the character ROM, and we're going to go into the character ROM to go and get that so we can roll it into the scrolling text. Right, as you know, the 64 memory map, the memory map of the 64 is layered because it's got some paging aspect to it, and the big paging aspect is where the character ROM is, because the character ROM is not normally visible to the CPU. It's only visible by default to the VIC chip. So this is how it's configured when you switch it on. So as you can see, the input output is the chipset that is available when you switch it on, not the character ROM. The character ROM is not available to the 6502 at this time. So there is a memory port, which is byte 1, which is the second byte of memory in the memory map that's linked directly to the CPU, and the CPU controls switching these chunks of memory in and out. So by bit 1, is that bit 0? So that's 1, 2, 4. So bit 3, or bit 2 if you count that as 0. So bit 2 controls the character ROM. So if it's got a 1 in it, input output's on. Gets a 0 in it, the ROM turns off. ROM is seen by the 6502 like this, and bit 1 yeah, controls the kernel, so it switches between the kernel and the RAM, and bit 0 can switch between the basic and RAM, and that's allowed. So we're interested in bit 2 because we want to make the character ROM available to the 6502. Problem is, you're switching out the input output chips, so you've got to do some coding to cater for the fact that the input output chips are not available to the 6502 while the character ROM is. So we have to do a little bit. We have to think of that. Now, if we're doing it on the VIC, that's a completely different animal. You know, the VIC has put RAM there, and there's nothing there. Never mind. It has up to 32k of RAM. The character ROM starts at 8000, and the input output chips start at, I think, 9000, and then basic starts at C1000 and kernel E, I think, yeah, E1000. Now the VIC doesn't have any switching, not by default, and it can't affect it. The only thing that affects it is if you put cartridges and it uses the hard lines to reconfigure the memory and stuff like that, mainly where to put the screen and all that. So there is a video out there that shows you how to do smooth scrolling. I'm not going to lie, it's out there. Grey Defender, he did one about a year ago where he did smooth scrolling across the screen, and the way he did it was he processed a pixel line at a time, and so he had like 40 instructions to do the roll in a routine, and so he did one pixel line at a time to do the scrolling. He also copied the character ROM into RAM. So the character ROM was like 4K, I think. 4K? 2K? 2K? Yeah, 2K. Yeah. I think. Anyway. And so you're taking that memory up on your 64 if you're copying the default characters in your text scroller. Now what I'm going to do is I'm not going to do that. I am going to dib into the character ROM as and when I need it, which means that we don't have to use any extra memory in terms of making this system work. And we're not going to process 40 characters at 40 bytes in every pixel line at the same time. We're going to be clever. We're going to process a character at a time to make that bit, that carry bit byte profile that we're going to put in the accumulator to work. So let's get right into it. So let's load the text scrolling program. Now I've already written it, I've cheated, I'm not doing it live, I've already written it. The reason is because it's took me 2 days to get this right, and I didn't want to record 2 days worth of video because you guys will get bored. Anyway, typo there. So standard thing, basic loader, and then we jump to a start scroller because I'm putting some memory items here. So we've got a matrix of the 40 characters that we're going to redefine in a matrix to make it easier to access it. Rather than trying to calculate it out, I'm using 80 bytes just as the matrix table to point to the right place in the character ROM for each character. Not the character ROM, the user defined RAM area, so I can instantly go to each character without having to do it. We've got the text, which is the same text as we've used before, and the starter routine is here. So the first thing we do, we're going to initialize the character area, then we're going to initialize the screen, and then we're going to tell the text scroller to work. So I'm going to run through the routines for you. Now, the initialize character area, that is basically what we're going to do. We're going to initialize the definable characters in memory to be 0, so we don't have a load of garbage to start with. I mean, I can show you if you don't do it, not a problem, but by default you want it to be a clean tape, so there's no characters in it. So that's what we do here. We initialize the two banks, or the two banks of characters that we're going to use to 0. Right, the initialize screen is basically we're going to clear the screen, and then we're going to put 40 characters on the top line. So we're going to start at 64, and we're going to put 64, 65, 66 and so forth for the next 40 characters on the top line. Dead easy. And then what we do is we set the VIC chip to look at memory 3000 for the definable characters, and we do that in the Neptune lander, so I've just carried the same theme. So once we've done that, we start with text scroller. So we find text scroller. It's down here somewhere. There it is. And the first thing we do is we get a character from the message. So this is the character get character from message. So we load the character in, and as you can see, it's an absolute value because we're doing some self-modifying code. We push the accumulator onto the stack because we want to store it away. We compare it with 255, which is the end of our string, and if it is, it goes to the end of text, comes here, pulls the character back off the stack, and then exits out. If we're not at the end of the string, we add one to this text, this byte location here. So text loader +1, text loader +2. We add a byte to it, so we move on to the next character. Alright, and then it pulls the character and then returns out. So we test for 255. If it's not equal, we go to still going. If it is equal, we come out of the text scrolling routine altogether, and that's it, the text scroll is finished. So in the still going, we transfer the accumulator, which is the number of the character we just pulled out of the message, to Y register, because the grab character is using the Y register as the character you want to grab. So if we go to the grab character, here we go. So here we are looking at, again, self-modifying code, which is we're going to alter this address here. And so what we do, we load in 0, we initialize this so it says LDA 00 when it starts, then we transfer the Y register into the accumulator, so that's the character number. So if it was character 2, it transfers 2 into the accumulator. Then we multiply it by 2, so it makes it 4, and then we roll the carry into the high byte. Then multiply it again, which multiplies by 4, roll the carry bit into the high byte, multiply by again by 2, makes it multiply by 8, roll the character into the high byte, and then store the accumulator into the low byte. And basically what that is doing is saying, I want to look at 2 times 8 number of characters, number of bytes. So if it's character 2, then that's going to be, God, my brain's froze, 16. Yeah. 2, 4, 8. Oh, my brain's froze. 2 times 2 is 4, times 2 is 8, times 2 is 16. Yeah. So it's 16. And that's the memory offset that we're going to be looking at, yeah? And then what we do is we add DO to the high byte. And because we're adding DO to the high byte, because that is where the character ROM is located. So we store that into the high byte, and now this is where we turn off the IO and then turn on the character ROM. So we need to switch off the interrupts because we're going to be swapping out the IO chipset with the character chipset. Then we load 33, which is the bit value for minus the bit with the bit for the character ROM switched off, and then we store it in 01. And as soon as we do that, the IO chips are now not available to the 6502. Right? So then we load Y with 0. We load from the character ROM offset of Y, store it in our location where we want, and we're writing specifically into character 40 because that's our character that's off the screen and you can't see it. Then we increase, we do it 8 times to grab the character definition, which is a cluster of 8 bytes. Then once it's the 8 byte, we switch back up, we load 37, which is with the bit for the character, the input output to be switched back on, store it back into 1, which re-enables the input output chipset, and so the 6502 can see it, and then we restart the interrupts, because as soon as the input output chips are back, we can restart the interrupts because That's the whole point of the interrupts. The interrupts are constantly checking the IO chips, and then we return back to the routine. And so the routine says, right, we've grabbed the character, so we're going to now start rotating those 8 bytes and taking note of the carry. So what we do is we load the accumulator with 0 because it starts off with 0, push it to the stack, and the reason we're pushing it to the stack is because we want to keep a copy, and then you run the routine, scroll over 1 pixel. Now what we're doing here is we are looking at the 40 characters because it's 0 to 39, and we're going to scroll the whole string, the whole characters over by 1 pixel. So that's why Y is set to 40, because that's 40 characters. Then we're going to load the character area, comma Y. So this is looking at our matrix that's going to get us the address location for that character, and then we store it here. So we load A with 0 because we're going to start with 0. We clear the carry to make sure we haven't got any residual carry effect, and then we load X with 0 because X is going to be our 8-bit counter. So I push the accumulator to the stack, I roll the accumulator, because when we're doing, once we're moving on to the next one, we want to roll that accumulator into the carry. So we roll the accumulator so it sets the carry, and then we roll the memory location of the character. So the carry, that if it was set in this roll, will then go into this side, and it will push out whatever was in this end column back into the carry. So then we pull back the original accumulator because we've destroyed it during this roll, and then we roll the accumulator, which brings the carry in from that and then pushes out the carry for the next byte, which then comes back here. So we increase it, we go back to rotate the 8 bytes, which is here, and then it does it again. So 2, 3, 4, 5, 6, 7, 8, 1 character done. We should have an accumulator that's now the carry map. So we push it onto the stack. We then subtract 1 from our byte location, because now we want to look for a different, subtract 8 because we've processed the 8 from our byte location, because now we want to move it on to the next byte. And so we subtract 8, that gives us access to the next 8 cluster byte. Then we pull the accumulator back here from here, because that is our carry profile. We decrease Y because we're saying we've processed number 39. Have we decreased it to 255? So that means we processed byte 0. No, we haven't. Go back to rotate next character. So it comes back here and then does the whole thing again, but on the next character, and then it does it on the next character and the next character and the next character and the next character until it hits all the 40, and then it jumps out. And that has only moved over the character, that character string, by 1 pixel, and 1 pixel only. It's not done the whole lot, it's just done 1 pixel. So when we go back here and we've done scroll over pixel, then we wait for the raster line to hit 200, and we just wait and wait. We pull our carry profile back onto the accumulator, clear the carry, and then we add 1 to the accumulator. Is that the carry? No, that's the position. Plank. Come on, John, get it right. Add 1. Compare it with sorry, it's not it's the pixel count. Add 1 to it, because now we're saying we're going to be on pixel number 2. Have we got to 8? No, we haven't. Go branch if not equal to do next pixel, which is here. So it pushes the pixel counter back onto the stack, and then does the whole thing over again. How about that for an explanation? Oh dear, I don't know if I've explained it right. Anyway, what we're going to do is we're going to run it. So, here we go. Don't blink because you'll miss it. So that's the assembly. Here we go. There we go. Now it's a bit jerky because I think that's to do with the emulator. And so what I'm going to do is I'm going to copy this program onto the 64. I'm going to run it on the real architecture because I'm sure this should be smooth scrolling. I think that's the I think that's just the emulator in this computer, because it's not the most powerfulest thing on the planet, this computer, this dev box. But as you can see, it's right, it's finished. It's smoothly scrolling across. So what I'm going to do is I'm going to fire up the C64. I'm going to copy this onto the C64. I'm going to run it on there and see what it looks like. So it should be a smooth scroller. So I will see you in a minute. Take care. Bye. Hello, it's Johnny here again. And in my excitement of getting out the 64 to try this out, I forgot to show you how it works. So what I'm going to do is I'm going to put it in debug mode so I can show you exactly how it works. And I've put 2 breakpoints in. One where we get the character and one where we start doing the pixel looping. Alright, so let's fire the debugger up. There we go, and we're using the C64 debugger. Let's put it to big screen so we can see it all. Right, we'll load the file in. There we go, it's loaded the file in and it's ran it and it's come to the first breakpoint. So if we move to the area, the RAM area that we're messing around with, there we go, it's all set to zeros, look. We can start stepping through this. So here we go, so we're going to get the next character. So there we go, so it comes in, it loads the character index, go through it, and that should have set the pointer. So here we go. Is it, so we've got, is it equal to 255? No, it isn't. So it carries on. So here we go. So now we're going to get that character definition from ROM. So we're setting our 2 points, which are here. So we're going to set it to 0 first. There we are. It's gone to 0, 0. Now we've got the character. So the character is now in A. So it's character poke character hex 14, which is what, 20. So we're going to times it by 2, so it's now gone 28. Times it by 4, now it's gone to hex 50. Times it by 8, so it's gone to 80. And then we're going to store it here. So this is the low byte. There we go, A0. Then we're going to load this one in because it could have gotten past the page boundary and gone 1. We're going to load D0, add it to this number, and then store it back into here. So it's gone to D0. Now we're going to disable the interrupt, bring in the character ROM, and then we're going to read DO80 and put it into 3340, which is here. So we're loading the first one, plonk, there you are, 7E. Load the second byte, third byte, fourth byte, fifth byte, sixth byte, 7 and 8. We bring back in the IO, re-enable the interrupts, and then we are going to run the scroll over 1 pixel, and the way it does it is, here we go, so we're going into it now. So 28 hex 28 characters, so that's 40. We are going to load the first, store it away, and the high byte, store it away. So that should be OA1, so it's here, isn't it? Yep, 3340. And then we're going to start the rotation. So we're going to start with 0, we push it on the stack because we want to keep it. We rotate the accumulator, but it's 0 because we started from nothing. Now we're going to rotate this. So watch this, this will move. Now that's F0. Have we got anything in the carry? No. So the accumulator still says 0, and we're going to do that for all these. Now we should get 8. We should get the accumulator of 0 because we've got nothing in there. There we go. Now it's going to work out the next character, which is going to be here. Yeah, 3338, and it's going to now start rotating that based on our accumulator, but the accumulator's got nothing in it, so it's going to go no. Right, I'm going to speed it up. So that's 1 pixel. That is 1 pixel moved, and as you can see, there's nothing on the screen. Now we're going to do another one. So here we go. We're going to go jump back into it. We're going to work out the screen, the memory pointer. There we go. It's 3340, and now we're going to rotate again. But this, with this being F, we should get a carry. Here we go. So rotate. There we go. We've got a carry look. Yeah, and it's gone to F8. So we pull back the accumulator and then roll that carry into the accumulator, and as you can see, it's now 1. And so if we do it again, these should all be 0s. So as you can see, the accumulator is going up by 2s, and then that's it. So now we're working out the next character, and the next character should be here, and because we're going to be rolling in the carry from the accumulator, this should go to 1. Here we go, 1. Excellent, and it carries on. So I'm going to press F8 to make it do the next pixel move. Yeah, and then the next one, and then the next one, and as you can see, look, it's just starting to come into view. So next pixel move, next pixel move, next pixel move. There we go, and that's how it works. We're taking the 8 bytes carry, put it into the accumulator to make it into 1 byte, and then we're taking that 1 byte and rolling it into the next character. And as you can see, speed it up, it's rolling across, and as you can see, we can see what's happening here. This is a great debugger. Right then, what I'm going to do now, well, I've stopped it, but if I take off the breakpoint and then F11, there you go. Pretty neat, eh? Pretty neat. Right then, now time to run it on real hardware, and let's see how it works on that. I'll talk to you in a minute. Take care. Bye. Right, I've got the trusted Play 64 out. Switcher on. Oh, isn't it nice to see? Anyway, back to the matter in hand. So I've loaded the program on my ST2IC. So let's load it in. Text star command 9. Do a quick list. Right then, let's run it. Let's see how smooth it really is. Look at that. And it's not bad. It's not bad at all. Well, I'm happy with that. That's smooth enough for me. But this is the third in the series of 4. This is probably the most faff to do this, because of all the manipulation of memory and stuff like that, because there's a lot of programming gone into doing this, and it's a lot of faff. Now the next one shouldn't be that much faff, because the next one will be using rasters to smooth scroll text across the screen. The only faffy bit about it is getting the timing right. Anyway, I'm happy with that. I love it. Right, if you like this video, hit that like button. If you didn't like this video, fine, hit that dislike button. Always leave me a comment. I try and endeavour to try and answer them all. And if you like what I do and you'd like to support me, consider becoming a patron of mine. All the money that's raised by that Patreon account goes back into the channel. And with that, I'll see you in the next video. Take care. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much. I'm green.